Thank you so much, Accel, for having us here, and thank you for the introductions. Actually, I know it said just me, but I also have my colleague Abhinav, who's here, who will kind of share the presentation with me. So it's obviously, but we're only representing Swiggy engineering and tech teams here, so it's obviously we're standing on top of all the work that's been done by the engineering and the data science teams back in the office who are actually at work. So, like yeah, and by way of introductions, my name is Jairaj. I've been with Swiggy for about 5 years. So I lead the data science, ML, and analytics functions. Abhinav is the director of engineering. One of the areas he looks into is our CRM platforms and specifically the customer service chatbot. So without further ado, and please pardon the PowerPoint, it's actually, we did a similar one for Process, which is one of our other investors some time back, so I'm kind of reusing some of the slides. So let's get it started. I think some of this was covered in Madhu's kind of overview, almost like we needed a framework to get going about how to think about generative AI and how to get it going in terms of an actual institutionalizing for it, right? So like obviously like everybody coming out of November last year or even early this year, a lot of FOMO, a lot of hype. So we really need to get a sense for like just kind of clear up the fog a little bit. So we did that by establishing a task force. It's like a cross-functional task force. We had like data scientists, engineers, and even corp dev and strategy people to just to get a sense for what is hype, what is real, how do we kind of just make sense of what it means for us. And obviously there is a board also wanting to know how we kind of do this, right? So as an outcome from that, I mean, in the task force, we kind of spent a bunch of time talking to startups, other VCs, other players in the other bigger players in the market, trying to understand the lay of the land. Once we kind of knew this was kind of for real and it's here to stay, we decided to kind of institutionalize that as a thrust for the company so that this kind of helps us with, like Madhu was saying, in kind of formalizing a bunch of these things. So instead of doing this as an offline POC, some engineer or some data scientist did it on their weekend, this is an actual prioritized initiative that can be either taken to production or kind of figured out as something that we want to ship or not ship, right? So that's what in the Q1 of, actually, I guess Q2 is Q1 of the financial year, but yeah, so in April, May, June, we kind of started out this thrust and with a single-threaded leader, which kind of helps us run this program as any other AOP kind of a program, which obviously, like Madhu was saying, it's like with some kind of flexibility around where do we push it down, where do we kind of abandon, what do we bring in, all of that, right? So I'll talk about a little bit about where some of that played out. What we thought was a big deal did not turn out to be a big deal, and how do we kind of make that like the plus minus of the prioritization. That essentially meant that we had some leeway in terms of funding and headcount, not a lot, but some dedicated headcount to do that. Obviously program management support to run the show. Like Madhu was saying, like evangelization mostly across tech teams, business teams, and obviously where rubber meets the road is actually we need to be able to showcase the results or not results in monthly reviews, right? And then the next framework was to figure out like how do we bucketize the initiatives that we can go after with generative AI, right? I mean, largely I'll talk about two modalities. We're not really kind of going after any voice modality kind of use cases at this point because largely it is text and image for us currently. So even there, three broad classes would be discovery and search as obviously kind of almost like the poster child use case for generative AI. Productivity, both internal and external. I'm kind of skipping the no-brainer use cases like developers adopting Copilot and so on. That's kind of a given. And then there is finally the automation. Now with this kind of background in the place, so we kind of started looking at what I'll talk about in the next few slides is some of the things that we've been able to push into production in experimentation stage or POCs and abandoned, all of the above, right? So let's start with the more like the obvious ones, right? So the obvious one is a kind of a text generation at scale. So on the left-hand side, so if you take a step back, so we have 50 million items in our catalog. A large portion of them do not have, like Karthik was saying, descriptions or images. People just upload their menu and they just stay. But obviously any e-commerce player knows that the richness of your catalog has direct impact on your downstream ability to sell, convert, all of that, right? That means that we need to be able to generate descriptions for our items at scale, which was a super hard problem to do back then, but kind of essentially becomes a prompt engineering plus pre-processing, post-processing pipeline, right? That's the other one is the AI generated review summaries. Again, comes down to prompt engineering with some guardrails. So both of these can be done at scale. Some of these things we do have like some learnings when we started out in like let's say April, and we were pointing, Azure AI was not really up and running back then I think, the GPT endpoint. We directly were going after the OpenAI ones, and we really ran into a bunch of scale type problems, right? So we would hit rate limits, we would hit token limits, and it would error out things and so on. So a lot of this pipeline here was kind of time spent on optimizing the kind of the checks and balances that we need, or at least basically almost like optimization hacks that we needed to do to make it run at scale. So for example, at the end of the day, or at least as of now, about 500,000 descriptions have been generated and they're live on the app, obviously with all the guardrails, right? So what happens is like, I guess there's a common theme in all of this. I'll get to that in the end. Common theme is that data is still paramount. Just because you have a ton of data doesn't mean you can give it to an LLM, it does magic. Doesn't work like that. So, and the human in the loop or some kind of an ops validation is extremely critical, especially if you're going to put it in front of consumers, right? So we spent a bunch of time initially prompt engineering, pre-processing, post-processing to get to that like almost 100% acceptance rate across these, both the reviews and the descriptions that we generate. So in the reviews part, it's a slightly more nuanced than a simple description, simply because we want the review to be truthful but not overly negative, right? So how do we kind of tweak that just enough to make sure that we have that the review is truthful but not really kind of bringing down the business of that particular restaurant or something like that, right? And also if you kind of following the literature in general, there is not a lot of, let's say, NLP kind of metrics for evaluating the quality of generated text. So there is no beer benchmark or some other blue score or something doesn't quite apply here. So what we ended up doing here is a lot of like in-house common sense metrics, right? So for example, if I'm building a review here, and if that review is going to be negative about an item that has been rated 4.5, that's obviously wrong. If I'm talking about something in my review snippet, and that's not even talking about their best-selling item, that's a defect. Or if the review is talking about some super obscure item in their menu, that's also a defect, right? So we kind of have these almost like came up with an SOP of sorts for people to evaluate what is the quality of this review and is this a good one to go forward, right? So we did a small-scale A/B experiment. That was, like Madhu was saying, it was pretty successful. We did see a good improvement in funnel metrics from people going from menu to cart and cart to order. And now it's underway in about 10,000 restaurants in Mumbai and Hyderabad as we speak. So I'll keep going. Next one obviously is the image generation one. I'll kind of, there's a bunch of slides, but we'll kind of go faster. As you can imagine, the basic problem is that how do we generate images at scale, but in the style of a restaurant that we care for, right? For example, if you want to generate an image of a biryani for let's say a local biryani place, that doesn't make sense for it to look like the biryani came from a ITC place or something, right? So the contextualization of that image to the restaurant that it is being generated for is super important. And obviously that's where all the prompt engineering-led solutions, off-the-shelf stuff doesn't really work. And also there's a large problem with the Indian context. Sure, they'll work for pizzas and so on, but as soon as you say rice bath or bisibele bath, you'll get some goo of stuff, right? So the first attempt for us towards this was to essentially use base stable diffusion with a control net guiding to what we call the image blending pipeline. So let's say this is the restaurant's background that we want to be kind of, this is almost like the context of the restaurant. Maybe this is a little bit of a, I don't know, Kormangla Social or something, some funky restaurant, and this is a burger that we want to be able to kind of generate an image for. And then and we call this the image blending pipeline, guided by a text prompt. This is a templatized text prompt. So which essentially tells these are the type of things I don't want to see, or these are the things I want to see, right? Negative means like ugly human face, no hands, no kind of people holding the thing, plate on a hand, all of that. So that kind of helps the clip encoder to ensure in the diffusion process, these things are kind of fuzzed out, right? You can arguably, you can say this image blending, like why do we need even generative AI for something like this? This is seems to be a classical CV-able kind of a thing, right? You have two images, why can't you just, okay, extract the foreground, slap it on here, and you have a blended image. But I think in the absence of generative AI, we would have done that. But what is really the difference you will see if you have done some of these, played with this, is that when you slap on in a standard CV type thing, the burger doesn't really sit on the base really well. It just seems like it's floating somewhere, or it doesn't generate well, right? So diffusion helps really with that blending part. See, for example, this something has like some cherry on top, but that went away, but it is really sitting nicely well on that, right? So this is the little bit of the pipeline that I talked about, and again, I didn't explore the stable diffusion part of it, but we can do that offline. Again, like I said, you start with an image, extract the foreground. I mean, these are classical CV models. There is no generative AI there. You get the image, and then we have two additional things. One is almost like an image bank of backgrounds, right? So fancy background, rustic background, all of that. That comes from our ImageDB. And then there is a small module to recognize the view part. Is it a top view, isometric view, side view? So that way we can guide the diffusion process to generate that. So all of that goes in here. ControlNet is essentially guiding with the background diffusion part, and then you have the textual input coming in here for the clip encoder, and then that's the image that gets generated. So there's a bunch of, this pipeline can be used for, obviously for about, let's say, 250,000 new images that have been generated, but because it's a blending technique and it's a classical CV technique, like at least the design pattern is similar, you can also use it for generating combo images. Let's say a restaurant wants to do burger and mud pie as a combo, but we don't have a combined image for it. It's actually, you can blend them together. And because for the diffusion process, a lot of the aspect ratio corrections also come for free, right? Tomorrow, so it's like a bunch of our images have like weird aspect ratios that are not really displayable in the app. They'll get squished and all of that. And we have a SOP for what the aspect ratio should be, but because the diffusion process is actually generating to that spec, it gets automatically corrected. Let's keep moving. But again, that's the first good start, or at least we first 3 months or 4 months, we went with that because we had a pre-existing expertise in classical CV and so on. But obviously we can do better. None of the previous stable diffusion was not really fine-tuned on any of our data. That is base stable diffusion controlled by some prompt engineering and some background thing. So, but instead now you have obviously with LoRa coming in, so you have this, essentially you can fine-tune these stable diffusion models with the LoRa checkpoints so that you can do best of both worlds. Now you have the text to image trunk, and then there is the image to image trunk, so to speak, right? And then obviously you have the chocolate Oreo milkshake, and I want it in a certain way, or whatever, and then the rest of the stuff is similar, right? So the reason LoRa helps here, and as opposed to just using the base stable diffusion, is because if you remember, stable diffusion or any of these models they suck at like very specific things. Like if you ask it to generate the photo of Barack Obama, it does an average job. But if you fine tune it with like 100 images, it will do a bang on job, but contrarily it will forget everything else. Or at least it will do a sucky job of doing the face generation as a general task. Right? So this is where the LoRa fine tuning helps, in the sense that we have checkpoints for classes of images. So for example, these are all, let's say, beverages. So there is a checkpoint for that. Then there is a pizza checkpoint. And then there is a, let's say, Indian style rice bath or rice items checkpoint. So we have like 35 such checkpoints trained, which covers about 80% of our order volume. And each of these checkpoints are trained on approximately 2,000 images, and inference is on a standard 16 GB GPU, right? So anyway, so the good part here, as opposed to the blending pipeline, is we get both text to image and image to image, right? The image to image part is essentially helping the model jumpstart the generation process a little bit more. So I'll give you some examples. So this is a grilled chicken burger. It generates it like that, the same. So it has no reference image directly from text coming from this pipeline. Here, slightly noised out tandoori naan given as a almost like a jump starting image with the text prompt does a much better. Here, so this comparison between, let's say, dry chili chicken is what we wanted to generate, and we also had like somehow managed to get a reference image for this from our catalog. This is what the image blending pipeline did. Hardly, like, see, the only thing you'll distinguish between this and that is it has blended the background really well. Some wooden thing has come as opposed to this flat thing, right? But that completely took it to the next level. It's actually dry, and because it's no longer a liquid, there is no point in the dish being like a bowl, a soup bowl. It is an actual like a flat bottom dish. So that level of control you're able to get with the LoRa-tuned checkpoints. Yeah, so I think again, all of this is again checkpointed and evaluated by human agents on a sample of few thousand images and whatnot. So approval rate by the humans, obviously we've been able to move it up by almost 20 pp. And the best image tag is within these two. If I gave you 3 images from each of these methods, which one is chosen as the best by the human evaluator, right? So obviously this wins out, but obviously there is no like rip and replace of this one, right? So there are corner cases where because we don't have a checkpoint for some corner tail dish family, we might still do this one because I have a reference image and I can't use this, for example. Right? So there is almost like an ensembling somebody was mentioning that is necessary to get it in production. Just to go back to there, I mean, all of this is batch process, nothing is online, so we kind of have these jobs run every week or every X number of days, and we clean that up. Just switching tracks a little bit, on the search part, I think Madhu mentioned this in the thing. So this is not really a generative model, so to speak, but I'll throw it in because it's a transformer model. Again, on this side is your regular keyword based, key phrase based, vanilla embeddings based search, but what we're doing here is a language model, not necessarily a large language model, just a language model based search to enhance the ability to understand stuff like that. Nobody's going to put keyword that says diabetic friendly ice cream in one shop, right? Or whatever, like Karnataka special sweets or Kerala special breakfast or whatever. So, and even that, healthy juices are for breakfast. If you try it today, it will really suck in providing the results. So that's the idea. Obviously with these constraints. So P90, 95 is like literally under 70 ms, and we're not using GPU at inference, and obviously it needs to know the Swiggy context. So that's the examples just for this. Like diabetic friendly ice cream, it's able to pick up. I didn't get the what would happen in our BAU search, but you can imagine we will really suck in that. Maybe it just grabs on ice cream and shows ice cream. South Indian breakfast again. I'm sure this thing does not have anything related to South Indian in its entire catalog, but it is still able to bring up the idli and dosas, right? So this is running in Bangalore, has been running in for a while, like Madhu was saying. We need to train people to start thinking about this in like basically open up the top of the funnel. So that to get traffic there, we need to kind of both get the top of the funnel wider and also run it longer. Just an L2 on how we did it. Again, like I said, it's a fine-tuned language model. It's actually, if you look at it, it's a 2019 one, not really that cutting edge in the generative AI regime. 100 million parameters. It's a two-step process. Start with any good information retrieval transformer-based model, as opposed like you can use looked at the beer benchmark and a few other things, and then we chose all-MP-net based as V2 as our starting point. Now it's a two-step process to kind of make it work for our context, right? Because as a regular language model, if you were to give this, this is the document that it has to understand. It has no clue about what bath means in this context. Probably has no clue what Udupi restaurant is, right? So how do we kind of, the first step is essentially trying to infuse that context into our model, which is basically the food delivery lingo. For that, we basically construct query documents using these, like query order pairs from historically, and we kind of, this is your document, and now you unsupervisedly tune it so that something like this is achieved. Basically, I mean, think of this as any masked language modeling task, right? So you randomly mask out a few tokens and force the model to learn that bath in this context is not really taking a bath, but more like a rice item. So such that something like this is achieved. Similarity between a rice bath and a bisivela bath is higher as opposed to a similarity between a rice bath and a fried rice. Even though as a token match, rice, the basic model would probably rank this higher. But in the food, given the food context, it needs to be able to learn this is higher than this. And that's just basically the masked out tokens, trying to learn them back. And the cosine similarity is kind of your distance measure. And the next step basically is to, now that it understands the lingo, now it really needs to do like a retrieval, make it like almost like how can it actually retrieve? So for example, if your query is juicy burgers, it needs to actually kind of retrieve McDonald's. McDonald's is probably never known for a juicy burger, but the fact that it needs to act as that retrieval it will come from somewhere here. This is the tricky part, because nobody has actually searched for such queries. The incidence of such queries is like 0.001 or something. Nobody has searched for diabetic friendly healthy ice creams. Nobody has searched for juices for workout. So how do we kind of jumpstart the supervision part? This is where I think, again, some of the folks, if you're starting out, the common theme will be that the data is key. So we were kind of almost like saved by the bell here, because we have an internal taxonomy that we've built over the last 3-4 years, which is called food intelligence, where we place each item in a 4-5 level deep taxonomy. You start from cuisine, regional cuisine, dish type, dish family, dish type, dish blah blah blah, all the way down to canonical dish name. So almost like think of it as each item is decorated with up to k attributes, right? So for example, let's take an example of an idli as an item. It will say dish category is breakfast, cuisine is Indian, sub cuisine is South Indian, and maybe dish family might be idli, blah blah blah. So you can map back into it. You can use combinations of these columns or data points to construct a query. A South Indian breakfast is a query that you can generate by jamming together regional cuisine and type category. Now that means that for that query this should be the answer. So now you basically used our almost like 50 million data itself to jumpstart our the lack of historical data of people actually asking these questions. So we use that, so like that's what it's saying here. It's constructed from item level metadata. We're using our taxonomy. So that way I can say that I have never seen anybody search for healthy juices for breakfast, but I know for a, let's say a watermelon juice, the metadata says it's a beverage and it goes well with something else and something else, and I can basically back construct a query for it. So that's once we have it, now you have a really large corpus to do it, and then the supervision can be any number of like the usual stuff. In our case, we ended up using what's called the MNR loss, which is essentially given a bunch of soft negatives and one positive. So how do we kind of learn it? I mean, largely determined by the model we chose and the batch size kind of construct, right? Now, given this, it should be able to map South Indian breakfast to idli and healthy beverage to some juice and whatnot. So that's the kind of the thing behind the model. So I'll quickly now switching gears a little bit to the productivity track. Again, still sticking to the text modality, right? Now you have like a spectrum of things you can do. Like the obvious thing to start with is text to text, like basically your summarization, question answering on your knowledge basis. One step higher is text to SQL. So it's not enough to just give me some summarized answer a precise question from me. What was my trend of defects last week? I can't just put out some generic answer. That has to come from a, let's say, SQL query. Or what was my payouts last week? So I can't like guess it, right? And similarly, obviously that's the holy grail. Can I just directly generate insights for people, right? So each of them in varying levels of almost like production, so to speak. This is the one that's closest. It's actually rolling out to a I think 9.5, 10K restaurants as we speak. It's basically like a usual GPT based, RAG enabled summarizer / question answerer plugged into WhatsApp through a Gupshup integration, right? Text to SQL is more involved. That is largely for internal use cases. Again, multi-level RAG to get like a SQL right. We've been kind of trialing it out with the internal teams to answer things like in our monthly business reviews or quarterly business reviews, or even just jump starting like the enable product managers, business managers to do self-serve on basic queries, because this is being exposed through Slack. You can ask a question, whatever I just said, what was my payout for restaurant ID XYZ last week? It should be able to spit out a SQL query there, right? And the holy grail is the text to insight. We have like demonstrated a concept for it, but again, it comes down to the data and business context is the long pole in all of them. I'll kind of maybe go through that a little bit. Again, this is the why of why we did text to text. As you can imagine, we have a help center. Restaurant owners can technically go there, but almost nobody goes there, and it's probably impossible to find the exact answer you're looking for. So instead, why don't we meet where they operate, which is the WhatsApp. So essentially, think of that, all of that help center made into a knowledge base that we can query upon. So this is basically the architecture. I mean, I'm sure it is very well worn. You can just follow the flow of information by the numbering part, right? Classic RAG, this is orchestrated by LangChain, just a one-step RAG for generating the answer. Again, this is a very controlled set of documents that we have, or at least the domain. So we've been able to achieve a really good acceptance rate of what a good answer makes, what's a good answer. But obviously, a lot of the production stuff has been around how do we kind of, I think when Abhinav will talk about it a little bit, how do we kind of, because the bots are not good at ending conversation. So how do we kind of insert those exit points so that I'm done here, can I get to a human agent, or here is your account manager, why don't you talk to them, right? But the tech part is basically this behind it. And we didn't use any, I mean, I think we started with ChromaDB, but went too fast now, but all of those should be kind of swap outable. This is the SQL part, more involved. This is where the data becomes super critical. So I'm sure some of you guys are working on like these conversational analytics insights startups here. One of the things that we've noticed as a drawback is people try to, almost like the sell is, okay, here is your company, why don't you come in and you throw all your data into us and I'll generate a SQL query for you. And literally like 100,000 tables, 10,000 columns, or whatever, I'm just maybe flip it, 10,000 tables, 100,000 columns. In our experience, the SQL generation in such situations has been really poor. So the design choice we've made is we kind of like prune it down to the domain that you want to answer. So for example, Instamart is a domain for us, food is a domain for us, but food we can kind of split it into a couple of domains within. And once we have it, and then we kind of collect the metadata about the tables. Now we're kind of dealing with, let's say, 300 tables and 1,000 columns only. Now we kind of collect the metadata, and thankfully in some of our cases we do have metadata stored in like Elation or Excel sheets or whatever, though it's a one-time task to kind of set this up, right? So columns, descriptions have to be embeddized, and then you have a bunch of metrics uploaded. So for example, I'll take a concrete example. Somebody says, what was my, how many refunds requests in the last month were denied? There is a technical term for it. We use something called block rate, but obviously nobody's going to exactly say that. What I just said might be a question somebody asks. But what we do in that metric definition is we will kind of preload some of these metric definitions and the also known as kind of definitions, and that's what we kind of maintain in our, let's say this, the DB. And then it's like a multi-level RAG to increasingly make the user prompt clearer and clearer. Let's say the question was, what was our refund denial rate in the last 3 months? And that is a query you want to generate. So first start with what is the refund denial rate? Like I'll see that, okay, that matches to block rate. And that's, again, all the green boxes are led by the LLM. And then it updates the prompt to, because each metric knows what columns and what tables it comes from. So we kind of increase that here. And then it's subsequently, that's exactly what I'm saying here. Basically, we take steps where we enrich the prompt in each step to add more and more info before the final query is generated. Even the final query part, we kind of do currently about 2 or 3 retries to make sure that it actually executes. I mean, if it executes, only if it is able to execute, we will kind of say, okay, this is a fully executable query that you can just now run, right? So that's the text to SQL part. Like I said, it is for simple logic queries. I mean, this is in one domain. We can largely get it right. JSON processing, complex queries, it's about like 70%. So that's why we're targeting more analysts and data-savvy product managers to begin with. I think there was a demo, I can show it offline. What are we doing on time? I think we're well over time. So maybe I'll skip some of these. So the text to insight part is a lot more harder. We can take this offline. You can imagine not just the multi-level RAG that's needed, but almost like a pruning of the search space that's needed. So if the question that is, let's say, what should I do to grow my business? This is a legit question people get. So sales manager, restaurant manager asks the sales manager, what should I do to grow my business through the next holiday period, let's say through NYE and Christmas. And that means that like that is in that person's head basically. So how do we kind of, and grow, what we ended up doing here is a intent mapping part. We just realized that the queries are just too broad. We cannot answer everything and everywhere. We will broadly map the queries. In this particular case, even the growth related queries can be submapped into like some 3-4 level deep intents. And again, this is in each case, it's the the LLM trying getting that. So at the end of the day, if for a given query, we kind of put it in one of these boxes, and in each of these boxes we have the historical corpus of answers that some sales manager has provided, some business manager has provided, all of that, right? So now that kind of reduces our search space of I don't know where to even start type stuff. Now I have said that okay, it's an organic growth related question, and this is what the historical people have said. Now I can take that as a starting point and go into actually the reason I put this one, like the question here is actually the ulta one, like why are my orders increasing? Nobody ever asked this, right? But the thing is the fact that the previous because of the previous way that is done, it is able to, given the past answers, it is able to contextualize and almost like invert the questions. Your orders are dropping because you didn't run ads last year, or your discounts were off, whatever. But if the orders are increasing, that it should know that I need to invert some of these things, right? So that's what that is doing. Once you figure out that it is search space and what bucket to answer in from, we kind of retrieve the top embeddings of the top K answers from the historical kind of the question or answer bank. But if you see there, the question is about answering increasing orders, but the first question is about order counts could drop. Order counts are also a function. Drop in average, everything is about drop because nobody ever asked this question. So this is almost like your adversarial testing to see if it actually is getting it right. The other thing we discovered as we went along is because the top K is not really right. In the scheme of things, we needed like a QNLI. This is a BERT model, question answer based things. We needed this filtering to do because it turned out that the top K, even if I did top 3, the real relevant answer was probably in the 7th position or 9th position. So adding this additional layer helped us bring that up because that just embedding was not doing that for us. And now in the approach gen, this is like in a loop. It basically, now it has like 3 or 4 data frames to operate on, and it generates Python code to generate the results. Basically it validates each of these. Okay, now this is what it has come up with as the hypothesis that it thinks is the answer for it, and now it's going to check all of them on the data, repeatedly running the code to, and then it generates these as the insights. Significantly higher than average, blah blah blah, because of this, right? But as you can imagine, this part is automatable, but the juice is all in getting that question bank, and the previous one about like the intent space and the search space reduction. And finally, there's the automation track. Abhinav, you want to, this is on the CC chatbot part. Actually, I think we can go to the next one directly. Yeah.
Hello. Hey, thanks, Jairaj. I'll quickly talk about the work that Swiggy has been doing on the automation of the conversational or the support center parts of Swiggy. Essentially the way you get your help for an order that you have placed with Swiggy. So let me just give you an overview of what kind of help exists. We have a decision tree based bot, which if you just look at it, it's essentially a list of predefined options, and the customer, if they are facing one of these problems, they can choose their option. They get some kind of resolution, and generally if you don't have a problem within these options, you are stuck, right? Which is why the CSAT score for this method is not very good. When it works, it really works well, but oftentimes it doesn't work for the customers, right? The second way here, which is a human agent conversation, where you actually talk to an agent, they fetch the information for you. They often talk to the delivery executives or the restaurants to get more information about their problem. And it's a much more organic way of getting help. But as you can imagine, it's expensive, not just because there's a human agent, but the agent industry itself is a high churn industry, right? So Swiggy almost has to retrain a lot of agents every single year. It's almost a new fleet every year, right? So the idea behind, idea for going for a LLM powered bot essentially was to, number one, provide this kind of experience to our customers, but also number two, remove the roboticity of the first, right? Where you have a fixed set of dispositions and it looks very robotic. So this is what we have today. We have this for a couple of dispositions today. This is still work in progress, but if you go to Swiggy's app today and place an order, you can actually talk to an LLM to solve some of your problems, right? So it's the first level build. It's built on one-shot learning. It's powered by GPT-4, and hence the costs. But it is essentially able to both remove the roboticity as well as bring in the conversational aspects, where you can actually type out the questions that you have instead of selecting an option, right? I'll just talk about some of the challenges that we faced while we built this out. Like you can imagine, Swiggy's data is quite dynamic. Most of the conversational bots are built on static knowledge bases, whereas this is a single order in Swiggy, which is like a 50-minute long order, has approximately 30 updates, right? So it is very dynamic data. We cannot pre-train a model to answer questions around that dynamic data, right? The second is what Jairaj touched upon, the steerability or driving towards closure. The bot can talk in an infinite loop, right? You can keep asking questions, it can keep going answering, and you can talk about the whole universe with this bot, right? So actually completing that conversation once the problem is resolved, that was one more problem that we need to solve. Jailbreaking or hallucinations are quite expensive in our context, because hallucinations end up in wrong answers, right? We observed that the bot or the GPT-4 sometimes answered questions which were not with untrue information. For example, it will say that the best way to reach out for help is to go on this phone number, but that phone number doesn't even exist, right? So similarly, jailbreaking can lead to very controversial content getting generated by this bot, right? And if one of those controversies end up on Twitter, like it will be a big PR disaster. So again, that was one more thing we needed to address while we were productionizing this. And then of course, since we are giving the customers an option to type out stuff, there is the problem related to free-form text, right? So your inputs are out of order. You're asking for city name, but you're getting restaurant name. And you need to limit the memory of the conversation, right? You cannot have a very long, like you cannot go beyond maybe 10 conversations in the past, because then that will just lead to unmanageable costs. So what you want to do is, you want to ensure that all the relevant information is within the last 10 messages. But of course, in the real world, that is not always the case, right? The customer might have given you his phone number at the top of the conversation, but that is now lost, right? And then of course, context shift. Customer came to you for a payment related problem, but now they have shifted to a delivery related problem, right? So how do you manage this context shift to within your conversation, right? So that is another like tough one, that something that we are still working on, to be frank, right? Some of the key learnings while productionizing this, I think these could be pretty useful if some of you are working in this area. Like latency plus token cost is like a problem for everyone. Some of the easier things or some of the smarter things that we were able to do is using the LLM itself to compress the context, right? So once you have generated your prompt, you ask the LLM that, okay, what is the minimum size prompt that can work for you, which will convey the same information that this large prompt does, right? So techniques like that, which are like basics, but kind of go a long way in reducing the context size. Then vectorization or RAG pipelines. This is basically for the last problem I talked about, right? Where customers are switching context. We want to detect that customer is now asking for a different problem. So a RAG pipeline based or a vectorized database will help us kind of determine that the given statement, right, does it still map to the context that we are currently loaded, or do we need to change the context, right? So something that has helped us. And then a lot of folks talked about latencies, right? So one cool trick is to use the streaming APIs. So Azure especially has a streaming API for working with GPT-4. So instead of a one-shot API, you can use this API and get gradual feedback that then you can design your UX that way, right? So a customer might see an answering coming in one sentence at a time instead of whole paragraph coming after 10 minutes, right? So that are some techniques. Jailbreaking, I think the simplest thing that worked for us was the second one, moving system message to the end, right? So you have a system message, you have user messages, and while the LLM is going through the whole prompt, it tends to forget what it read in the start. So bring the most important things towards the end of the prompt. That will help you kind of get the LLM to adhere to your most important concerns, right? And then of course, system message to limit the context. Like the LLM should not be answering questions about what is the fifth moon of Jupiter, right? It should be only talking about Swiggy and what can happen with an order, right? So that, and then few shot prompting. So over time we discovered that one shot is not enough. For some use cases, we need to use few shot prompting to actually get relevant answers to the customers. And finally, when you're taking it to production, you're deploying for customers, VPC firewalls, it's somewhat obvious, but tenant isolation is something I'll say was a big learning, because like Jairaj mentioned, we are learning a lot of use cases in Swiggy. Once we productionize this, the other use cases were limiting or rate limiting this use case. So we needed to do some tenant isolation, and that kind of helped us out. So yep, that's pretty much it. Jairaj, over to you.
What's next? I think we can just wrap it up. Okay, I think largely some learnings. Some of this we already covered. We took a little bit of a flailing in the first 3 more ones, kind of looking at, because what looks cool at the beginning may not actually pan out. So I think that little bit of that breaking in period was there for us. I guess in hindsight, I would say conserve the bandwidth, because there's always going to be like 10 companies or 10 things that are hitting at you to say, we can solve this, we can solve that. So I think that's in hindsight. And the huge delta between what a cool hackathon project is versus what it can do in demo, or even a productionizability of it. And accordingly, that means you need to manage expectations. And then this is the hard learning. I think some cases came about like custom models, open source models. At least for the cases, the text cases, it was hard for us to beat GPT, and that means that cost and ROI trade-off continues to be a problem. Abhinav talked about the hallucination is a problem. That means it needs a lot of internal testing, guardrailing, and all of that. This is an early on, but I guess maybe with the current thing also, it might still be valid. We moved away from using directly from OpenAI to Azure AI. And also, all of this means that we kind of fine-tuning is usually kind of a last resort for us. We kind of exhaust all the off-the-shelf API versions, and only then we try to see, okay, now we need to do something ourselves. And again, we didn't see a lot of pull for all of these chatbot use cases for customer queries, because I'm sure some of you guys have seen, once the initial novelty is gone, it is hard to keep it running. So we kind of haven't productionized or thought about any chatbot for food ordering type use cases. And then the other thing was about just be dispassionate, because things move so fast. You can't like have a sunk cost fallacy, that blending thing we spent on 6 months or whatever, but something else came along that actually does significantly better, so you have to replace. This is a huge learning. Just because you have data doesn't mean it is usable in a manner right away. Like how you construct your corpuses has a large bearing on what the level of usefulness you will get. And the long pole for us is also this, like a lot of this data does not actually exist. Like many startups will come to us and say, give us the data, we'll do it for you. We don't have that data, it's not codified, it's in somebody's head, right? So even when we did like the pilots with the bigger companies, that's what we can only give you so much data because we don't have it. That also means Copilot for X use cases are kind of sexy to think about, but hard to actually make it happen, because when a sales manager goes to a restaurant manager, they're not writing it down. We don't have a concept of somebody coming back and entering it into Waymo saying that I pitched this, I did that. So lots of porous or at least lack of information. And again, obviously goes without saying, there isn't, at least so far we haven't found any slam dunk use cases that kind of change the step function change in our top line or anything like that, right? A lot of it is what used to be hard before is now suddenly easy, but doesn't mean it's like a super value generating right away. Easier to find automation tasks rather than top line growing ones. human in the loop is still a kind of a very critical piece of the chain. I think that's it. Don't forget to order on Swiggy.